Hello friends, welcome to Pravegaa Education. So here I am and going to discuss one of the good question from the TIFR exam 2024, and this question is basically from the condensed matter physics and with the subtopic of X-ray diffraction. Okay, it's a XRD question. It's a very important concept as far as the condensed matter physics course is concerned, and very often you can see the question from the X-ray diffraction and their subparts. So the question is, an X-ray of wavelength 3.1 angstrom incident on the 110 plane of a cubic lattice with a lattice constant small a produces a second order reflection at theta 30 degree. So the wavelength which is incidenting is 3.1 angstrom, and it is incident on the 110 plane. Okay, so the plane is also given to us. The plane is given to us, that is HKL is nothing but 110. Okay, and they are saying the lattice constant is small a, okay, because the crystal is cubic, and we have to acknowledge that produces a second order reflection. That means the value of n, the order of reflection, the order of basically you can say the diffraction will be 2. This is the second order, right? So n is equal to 2, and the theta is 30 degree, and we have to find the value of a, that is the lattice constant. But the point is, student, if you see here, the theta is given with a normal. If you can see, the theta is given with the normal, but we all know that in the X-ray diffraction, we always consider theta of the incident radiation with the plane, not with the normal. In the question, the theta is given with the normal, and this is 30 degree, and we have to consider the theta with the plane. If this is your normal, so this is given to you, this angle is given to you. I am representing this by theta dash, let's suppose. So this theta dash is given to you, this is 30 degree, but we need the angle with plane, right, not with the normal. So this theta will be nothing but theta will be 90 minus theta dash, and this theta will be 60 degree instead of 30 degree. So it's the main crux, or you can say the main point of this question was lying here at this particular point, that the angle should be with the plane, not with the normal. So the theta is 60 degree, n is 2, lambda is given to us, plane is also given to us. Now we can apply the equation, the Bragg's equation. It's a very famous. This is given as 2 times of d sine theta is nothing but equal to n lambda, and d is our interplanar spacing. Correlation with the lattice constant is given as a over root under h square plus k square plus l square, with the hkl is a Miller indices. So put in the equation. So we will get 2a sine theta divided by root under h square plus k square plus l square, and n is 2 because they are talking about the second order reflection. The value of n is 2 here, so this will be equal to 2 times of lambda. Okay, so 2 and 2 cancel out. The value of HKL is 110. So this will be a sine theta. Theta is 60 degree, right? It is 30 degree, but we have considered the theta with the plane, so it will be 30 degree. Sorry, 60 degree. So a sine 60, and this will be equal to lambda times root under 1 plus 1 plus 0. Okay. So a is given to us. Lambda is also given to us. So let's put the value here, and we'll get our answer. So sine 60 is root 3 by 2. Lambda is 3.1 angstrom, and this will be square root of 2. When we will solve this, we'll get the lattice constant A is nothing but is equal to 5.06 angstrom. This is your final answer, 5.06 angstrom. And if you see the option A is correct. Okay, so this is the correct option. Okay, so this was a question, it was a very easy question, and most of the time in the TIFR exam or in the NET exam, whenever they ask a question from the Bragg's concept or the X-ray diffraction, they usually do this type of thing because it's a very minute thing. Student basically ignore all this concept, right, in a very general way. I'm not talking about all the student, but yes, in general, student make mistake at this particular point, that they have to consider the angle with the normal, not with the they have to consider the angle with the plane, not with the normal. Okay, so this was the question. I hope it will be fine, good for you. Thank you so much.